Global aviation is expanding at a staggering rate. Rising tourism, international trade, and rapid economic development mean there are more flights connecting the world today than ever before. This chart shows projected global demand for aviation personnel over the next 20 years. It reveals a massive surge, requiring hundreds of thousands of new professionals. To support these flights, the industry relies on controllers, dispatchers, and engineers distributed across international hubs. Despite decades of rapid technological advancement, keeping planes in the sky remains deeply reliant on a massive, continuous influx of highly trained human beings. Historically, flying meant exactly that. An aviator physically manipulated the controls, relying on manual physical input and analog dials to keep the plane aloft. Today, modern aviators act more like systems managers. Advanced avionics, like flight management systems, the central computers that automate navigation, and fly-by-wire technology, which replaces mechanical linkages with electronic interfaces, handle the physical flying through almost every phase of a flight. A pilot's minute-to-minute workflow has shifted away from manual steering. Instead, they monitor system logic, manage fuel consumption, and analyze incoming weather data while the autopilot tracks the route. Curious, slightly slower pace. Which brings us to a contradiction. If computers and advanced avionics are highly capable of flying an aircraft from takeoff to touchdown, why is the demand for human pilots higher than ever? There is no denying that automation has drastically improved baseline aviation safety. By taking over routine tasks, these computers minimize standard human errors and significantly reduce pilot workload during long flights. But this dynamic introduces a hidden threat, known as automation complacency. Excessive reliance on automated systems can slowly degrade a pilot's baseline hand-flying proficiency. When the automation drops out due to a sensor failure or extreme weather, these pilots suffer dangerously delayed response times. The very systems designed to guarantee a perfectly safe flight become the primary threat if a pilot loses the physical ability to intervene. To combat this dependency, airlines actively force pilots to turn the computers off. They require manual flying during clear conditions and mandate raw data approaches, navigating using basic radio signals rather than advanced GPS. They also undergo upset prevention and recovery training, or UPRT. In the simulator, crews are thrown into extreme, unautomated scenarios, forcing them to manually wrestle the aircraft out of dangerous attitudes. The modern pilot requires a highly specific cognitive balance. They need deep technical knowledge to quickly diagnose complex system failures, combined with the raw operational experience to make split-second, manual corrections under extreme pressure. Aviation safety is never achieved by choosing between the human and the machine. It is achieved by deliberately honing human skill to serve as the ultimate failsafe when the machine fails. This reliance on human capability extends far beyond the cockpit. A safe flight requires continuous interaction among a massive network, including air traffic controllers, dedicated flight dispatchers, and ground maintenance engineers. To manage this network, the industry uses Crew Resource Management, or CRM. This formal training system is designed to optimize teamwork, resolve conflicts, and manage external threats by ensuring everyone communicates clearly. A single misunderstood clearance or a tiny breakdown in communication can instantly bypass every technological safety net on board and lead directly to disaster. That is why the International Civil Aviation Organization implemented the ICAO Level 4 language proficiency standard. It mandates a strict baseline for English fluency across global airspace, specifically designed to prevent fatal miscommunications. Elite communication skills and effective team leadership are as critical to an aircraft's survival as its engines, its wings, or its software. Looking to the immediate future, artificial intelligence is already entering aviation operations. AI is being deployed to handle predictive maintenance, optimize fuel burn across long routes, and assist with complex flight planning. But AI has fatal limitations. It can compute massive amounts of data, but it lacks ethical reasoning, dynamic adaptability, and the emotional intelligence required to lead a panicked crew or reassure 300 passengers. The evolved role of the modern aviator demands a professional who can seamlessly integrate traditional stick and rudder flying skills with deep technological competence. Technology has not replaced the pilot, it has simply upgraded the job description. In an increasingly complex and automated world, human judgment, adaptability, and leadership remain the irreplaceable core of aviation safety.